All right, let's start. Good evening. Actually, thank you for showing up. I do appreciate that you prefer this session over the World Cup. But I mean, the game, 40 minutes in, just one goal, it's a snoozer. So I think that's a much better use of your time here. And of course, there's replay as well. So yes, thank you very much for attending NDC. It's been a great conference so far. Almost over, just one day left, plus this slot. My name is Christian, and one of my topics of expertise is web application security. And as such, I am working with many customers to make their web applications secure, sometimes very early in the process and sometimes very late. And in that capacity, I see, the same kinds of successful attacks all over again. But on the other hand, I also see that against very common attacks, there are excellent countermeasures. No matter where I go, for instance, these days it's really, let's say, hard to find SQL injection, right? Of course, because developers know all about SQL injection, hopefully, and on the other hand, of course, because the tools and the frameworks make SQL injection really, really hard. On the other hand, there are some attacks where they may be a couple of years old, but still there are not countermeasures everywhere, or there are new twists to those attacks where common countermeasures do not work. So the idea behind this session is that I'll just show you some things that, at least in my biased experience, pop up more and more often. We'll have a look at it. Sometimes we'll see stuff that's actually pretty old, but still works now, maybe even better than ever, and maybe some stuff that's also relatively new. And so I hope that even though you may already know some of the attacks or risks I'm about to present, you will be able to take something home with you and get some inspiration and maybe also some good fun. Now, as I said, I tried to talk about kind of trends, and I think I'll start with a trend that is, I think, 2 decades old. I'd like to start with cross-site scripting. Now, probably you are thinking, wait a minute, I kind of signed up for the session because of trends and new stuff, and then he's showing me here this CFE details curve, and if I go to the very left side of it, I can see, well, cross-site scripting popped up 1999, 2000. That's actually correct, but on the other hand, if you go to the right-hand side of that graph, you'll see that last year was a record year for cross-site scripting vulnerabilities, at least in that ZVE metric. And considering that 2018 is almost 50% done, if you extrapolate that, 2018 will be another record year for cross-site scripting. And that I find this really depressing, actually, because it seems to me that cross-site scripting doesn't go away, and I don't understand it. I mean, depending on the technology stack, cross-site scripting is getting harder and harder. So here at NDC, I think the technology most widely used, according to the surveys from the previous years, is the .NET stack. So if you're using ASP.NET MVC, right, no matter if core or regular old MVC, and you use the Razor view engine syntax, then it's almost impossible to create cross-site scripting, almost. Not completely, but almost, right? And so I kept wondering, why is that the case? And I also meet a lot of developers who are not really afraid of cross-site scripting, because they think, cross-site scripting is just alert one, and that there's no real danger and threat going on from that. So I thought about this for a while, and then I remembered that OWASP once kind of created 3 types of cross-site scripting. So they segmented all cases and vectors of cross-site scripting into 3 buckets. And most of the time when we talk about cross-site scripting, we talk about type 1 cross-site scripting and persistent cross-site scripting. It's a bit rarer, but very, very dangerous. And non-persistent cross-site scripting, which is very common and a little bit less dangerous, but still. And there's a third one, DOM-based. Because with, let's say, regular cross-site scripting, there is involvement of the server. With DOM-based cross-site scripting, everything happens in the client. And now it's getting interesting because if you look at the schedule of the conference, there's a lot about spas and frameworks like Angular and such, where a lot of logic happens in the browser, and the browser is also processing user input or something that could be manipulated, for instance, the hash fragment of the URL. And that's one of those cross-site scripting areas where many people or many developers just do not think about the dangers involved. Now, I would like to show you an example which is quite common to something I've actually recently found. So this is real world stuff, but of course I simplified it and kind of anonymized it, where it's not. Technically, it's not really type 0 cross-site scripting, but it's pretty close because stuff happens on the client and we have to be super careful. Now, I've extracted this really simple, let's say, proof of concept. So I'm using actually XStudent MVC for that example, but I have another technology later in this talk. And as you may see, I'm using an older version of Visual Studio and the old ASPX viewform engine. That doesn't change a bit about the attack, but the older stack is important a bit later on today. But this would happen with Razor as well. Now what I'm doing here is I have something in the viewback object. So if you're not doing MVC, that's a way of passing information from the controller to the view. And I'm outputting it, and I'm using the colon syntax here. And colon means HTML escape. So basically what happens here is that the value is run through HTTP utility.html escape in order to prevent cross-site scripting. And now I'm doing some fancy jQuery magic here by just writing the data I get into the output field. Okay? So really, that should be extremely sound and absolutely harmless. Furthermore, if you want to have a look at the action method, what I'm basically doing is I have a look at the query string parameter name, and if it exists, I just put it in there, which leads to this situation. If I call this page with no argument at the end, I just get whatever unknown. And if I choose to append something here, so let's just say name equals Christian, then hooray, it says Christian. Okay, great application. And of course, it's as I said, real world. Well, actually, the application was not too far from that, actually. So there were elements in the URL which then appeared on the page. Think about search. And of course, there's cross-site scripting protection, right? Why is there cross-site scripting protection? Well, I could try to enter something like script alert 1 in here, but what I then get is script alert 1 as verbatim text. The reason, of course, being I'm HTML escaping the output. So if you look at the source code, we see that the HTML special characters, in that case, the opening and closing angle brackets have been encoded, right? Now, the first time you heard about encoding, you probably heard encode according to the context. So we do HTML encode because we expect that we use the data in HTML. Therefore, we only escape special characters that are special characters in HTML. Sounds logical. But let's have a look at the source code again. And if you look closely, we see we are not in an HTML context here. We are in a JavaScript context. And so many developers, or not many, let's just say some developers tend to use HTML escape everywhere, but are not limiting their usage of user input in an HTML context. Now the problem is that, of course, in JavaScript, we have additional special characters, not just the 5 special characters in HTML, we have more. And since we are here in the middle of a string, of course, the backslash comes to mind. Now, with the backslash, we can do a couple of things in JavaScript. We can do escaping. We can have special control characters. And what we can also do is we can use character codes for some special characters. \x and then the hex character code. Now, I have to admit, my memory is not very good. So I can't remember any hex codes. But my favorite website, ASCIItable.com, conveniently does. So let's look for the angle brackets, because those were the ones that were escaped before, right? So opening angle bracket is 3C, or closing angle bracket is 3E, okay? Well, then let's go back here. Let me try to zoom in so that you can see this a little bit better. Okay, so what did I say? 3C, right? And that is then 3. And that should be 3C. And that should be 3E. And you already see, right? Now we have cross-site scripting. Now, that's a very typical problem. So just remember, always use context-specific escaping. You may have noticed I'm demoing this in Google Chrome, and Google Chrome and all the other browsers, except for Firefox, that's why I usually like using Firefox in presentations, they have a built-in cross-site scripting filter, and that cross-site scripting filter has some heuristics, right? It's looking for input that then shows up on the page and looks for certain patterns. But that's not one of those certain patterns, right? Because there is no script tag. There's just some funky encoding, and that's what makes things so utterly dangerous. And that's why I think cross-site scripting is still there. Now, let me quickly answer the question I posed myself at the beginning of this talk. Why are people not afraid of JavaScript? And I think it's because of demonstrations like this, right? Alert 1 is embarrassing, but there doesn't seem to be a threat. And let me just really very, very quickly, and I'm aware that practically all of you will know that, but let me just reiterate it because it's so important to me. The reason why cross-site scripting is so dangerous is the same origin policy and a pretty unfortunate wording. In my opinion. So let's just imagine we have our website here on example.com, port 80, HTTP as a protocol, and the same origin policy says, and I'm simplifying things a bit here, the JavaScript has access to everything on the same origin. Simplified, I know. And the origin is a term that's been standardized by IETF, which means scheme, protocol, fully qualified domain name, and port. They have to match. I hate the word origin. I really do, because it's misleading. Let me show you why. So imagine on that page we have like 3 blocks of, or 3 parts of JavaScript. Top left, inline JavaScript. What is the origin of that inline JavaScript? Yeah, obviously it's HTTP example.com port 80. I do then a script src reference to the file script.js on my server. What is the origin of that file? Well, happens to be HTTP example.com port 80. And finally, I'm using a JavaScript library. I was using in jQuery here just because I've just been using jQuery in my example. And I'm loading this from a CDN. Now, what is the origin of that JavaScript file? And when you think about origin, kind of where does something come from? The intuitive answer would be, yeah, code jQuery com. But of course that's wrong, because if the origin in the context of same origin policy of that JavaScript file was code.jQuery com, it would not have access to any of the DOM elements on my page example.com, right? Same origin policy prevents that. Therefore, the origin of that file is also HTTP example.com port 80. I find this utterly confusing, so I like talking about the security context in which something runs. But that, of course, means if you have cross-site scripting, if someone injects either inline code or references a JavaScript file residing on another server, that file has the origin, the security context of your website. So it can do anything our JavaScript files on our server can do. And that's what makes cross-site scripting so extremely dangerous. And that's what many people do not really consider. Now, if we start on a green field, in my opinion, and we have a modern application, modern stack, then cross-site scripting should be dead by now. It should really be dead. Because of one very simple thing, content security policy. A W3C standard which uses an HTTP header that the server sends to the client, and the client then limits what it loads and what it executes. So for instance, you can tell the browser with this, whenever you load something, images, style sheets, fonts, JavaScript files, only load them from the current origin. The single quote self here means the current origin. Right? And that's pretty interesting. So now, let's just assume we have a cross-site scripting vulnerability on our site, or on our page in that regards, but we have a content security policy like this in place. The attacker cannot do script src equals http://badserver.com/badscript.js because the server where this file is on is not the current server of the current page. So the browser refuses to load it and, of course, to execute it. What's the second attack vector? The second attack vector is script and then some bad code like alert1. Forgive me for using that once more. Now, one of the side effects, side effect sounds like you don't want this. One of the intentional side effects of content security policy is if you have a content security policy that takes care about JavaScript, and that one does, then inline code will not work any longer. So, and I mean, this sounds like very bad news, right? But let's just put these thoughts behind us for 15 seconds. If the attacker cannot load a JavaScript file from his server, and if an attacker cannot run inline code when we have a cross-site scripting vulnerability, there is only one cross-site scripting vector remaining. And that cross-site scripting vector remaining is, of course, script src equals badfile.js. So yes, if there is malicious code already on our web server and we have a cross-site scripting vulnerability, yes, that code can be run and executed. On the other hand, if an attacker manages to upload bad JavaScript code to our server, cross-site scripting would be the least of my problem if I were you. So that's really a very effective mechanism. Now, I have a page here for you, and just want to briefly show you the downside of that and why cross-site scripting there still might be a relevant problem. So this is another very complex app I've prepared, and it shows the logo of the organizer. I was using an image, so if you go to the NDC Oslo website, that's not an image logo, it's a text logo. But Programutvikling, the company that's running this, they have this logo. And I get the current time. Now, the code used to achieve this effect is, well, also kind of simplistic. So I've stolen the logo from the website so that I don't have to pay for hosting and bandwidth. And then I have here a diff element that does an output. And then I'm using the underscore JavaScript library in order to have a templating language and templating mechanism. And then I'm running this fantastic JavaScript code that queries the server every 1,000 milliseconds for the current time, because I work in security, so I can't rely on the client time. I have to rely on the server time. And in the JavaScript file here, I basically set up this template here, and whenever I get the current time back from the server, I apply the template, and therefore the time is updated every 1,000 milliseconds. The problem here is if I run this, but in order to be more secure, I use a content security policy, for instance, the one we saw on the slides, then, well, some things might change, and let me put it that way, not to the better. I'm reloading. And so the time is gone, the beautiful logo is gone, and the font is smaller, even the background color is gone. And the problem is, I run into several issues by applying that content security policy on that, of course, contrived example. Here, I'm loading an image from a remote server. The remote server is not part of my policy, so I have to look for all the places where I load remote images, remote fonts, web fonts, for instance, tracking scripts, etc. Bitcoin miners I put on my website, I have no idea, and have to put them in the content security policy. Inline styles are gone as well. I talked about inline JavaScript, but that applies to inline styles as well. Then I have here set interval, and then I'm using a string as an argument. This is the same category as new function and eval. By default, eval and friends are also deactivated by having a content security policy. So I need to refactor that. Well, then it's inline code, of course, so I would need to move it into an external file. And if I do all this, right, so I refactor, I turn the string into an anonymous function, I move the inline code into an external JavaScript file, I turn the inline styles into classes and then link to a style sheet, the application would still not work. Why would the application still not work? Because underscore. Don't get me wrong, I'm not dissing the underscore JavaScript library, not at all. I was just using it as an example. But the underscore library, as many others as well, they are using eval in order to run their templates. Technically, they're using new function, but it's the same thing. So I would either need to get rid of that library, or I have to disable the protection for dynamic code evaluation in content security policy. Well, I can do that, and I would say the attack surface doesn't get much larger by that. What I could also do, because I'm lazy, is I could deactivate the inline code execution protection. But if you do that, you have a cross-site scripting vulnerability. All your protection is gone immediately, right? I could talk about this on and on for hours, but I just want to show you, yes, there is a solution for many cross-site scripting scenarios. If you have a greenfield application for, well, practically all cross-site scripting scenarios, if you have a legacy app, there might be work involved. And there are techniques and approaches how you can do that, but it doesn't come for free, especially for legacy applications. Just think about, maybe some of you have done ASP.NET Web Forms in the past. And ASP.NET Web Forms means two things. One thing is lots of inline styles and lots of inline JavaScript code, right? So all of these would cease to run, so we would need to find ways around it. There are those ways, but I just wanted to tell you that. Now, these were classical web applications, but since we have had a look at templates, another topic that I see popping up quite often is template injection. I mean, no matter what kind of client-side framework you're using, there's always a kind of a template, and in the template you can do some data binding, and sometimes you do not just bind values, but maybe some more complex constructs as well. And one of the things I would like to look at now is Angularjs. Please note, Angularjs, I'm not talking about Angular 2 or higher, because they changed the mechanism. So the things I'm showing you, they do not work exactly as that. But essentially, they were fixed because they're using a different approach. But I think the approach from Angular 1, which, I mean, is still under support, right, is a quite interesting one. So we have expression binding in Angularjs, right? The Angular team implemented a sandbox. So when you have those expressions, they are not always just run, they are just, converted into code if possible internally. So if you just have binding syntax, double curly braces, 1 plus 2, and then that is turned into a named function like this here shown on the slides. And that was like a cat and mouse game between the Angularjs team and various security researchers, because the researchers always found new holes in the sandbox, and then the Angular team closed them, and then they found new holes in the syntax, and then the Angular team closed them. And in Angular 1.6, the current release version of Angularjs, they just removed the sandbox because they essentially said, A, we will never be able to fix everything. There will always be a new approach that we didn't think of before. And B, we found out by removing the sandbox, the performance went up by, I think, 9%. Yay for performance! Yeah, good point. Actually, good point. Actually, let me show you real quick if you're interested in seeing that. So very simple. Example here as well. I'm loading the latest version of Angularjs 1. It's 1.6.10 directly from the CDN. Let's see how that works out. And then I output here something. I also do HTML escaping because I'm super afraid of cross-site scripting, right? And in my controller, all I'm doing there is I'm taking the, in that case, the parameter called Q, and well, then I output it. I don't have a content security policy. Even if I did for Angularjs, I would need to enable eval. So it's a bit of a, let's say, a complicated story. Now, if you have a look at that in the browser, let's just see if it loads the thing all right from the server. Yeah, okay. So perfect. I get the output right here. Amazing. Now, what I can, of course, do is I can, and that's the main problem here. Once again, I have additional special characters. I'm in the HTML context, but since this is an Angular page, the curly braces suddenly are special characters, right? So I can do data binding. I could try something like 1 plus 2. Right? But on the other hand, 1 plus 2 is a bit boring. What I'm doing instead is, depending on what I put in here, and since there's no sandbox anymore, I just have to find a way to execute code. And so someone found out that if I do constructor.constructor, I am on the level of function. So this is a function constructor, so I can do alert, or let's say alert 2, just to show how varied these attacks are. And then I execute this immediately. And now I have cross-site scripting again, right? Although I had HTML escaping. So once again, remember the context when doing the escaping. Otherwise, you will run into issues because cross-site scripting just, it could die, but it does not. And coming back to content security policy one more time, of course, if you have a template engine, if you have a client-side framework, MVC, MV, whatever, you have to check whether it's compliant with content security policy. I was once at a customer site and they were using Apache Wicket. And I've never seen this before, and I've never seen this ever again, because that framework, or at least how they were using it, is just outputting inline JavaScript all over the place. So the whole page is set up by blocks of inline JavaScript. And there was like one entry in the bug tracker. And yeah, how about we make this content security policy compliant? No one is using content security policy. That was the reason a ticket closed. And there's some truth to that. Content security policy, especially if you have not always used best practices, if you have used inline styles, inline JavaScript, then it takes some effort to implement that. All right. Next topic is the new number 4 in the OWASP Top 10 2017, the first time it ever shows up in that list. It's XML External Entities. And this kind of, I mean, the idea behind that attack is way older, but in the web it kind of showed up about 4 years ago. And the idea here is that, actually, let me first tell you the idea. So we have an XML file, and in that XML file we can have entities, right? We know entities from HTML, like ampersand, LT, semicolon for the opening angle bracket. Now, browser knows what that entity means and then, handles it accordingly. What we can do in XML, though, is we can use entities, and then we can add the information in the XML file, what this entity means, what it resolves to, and this can lead to quite interesting aspects. Now, let me show you this. Okay, I don't see anything. You don't see anything either. Where's my window? Okay, there we are. So this is an XML file. And we just assume we have an HTTP endpoint that accepts XML. It could also be, an import that runs every night, and this XML comes from another service. But somehow the attacker can control the XML, and the web application is processing the XML. And again, I simplified it a little bit so that I can show it directly in code. Now, so that's the XML file, and the XML file contains one element called a tag. which doesn't attack anything. But within that element, we have a new entity, XXE. XXE is nothing that the file is, or that XML knows. However, conveniently in the same file, I explain the XML parser about XXE, what kind of entity that is. It's a system entity and it points to a local file. Local on the system on which the XML parsing runs. Means when a web server parses and processes that file, that is a local path on the web server. So we are loading here a file. Actually, let's not use the PHP file. Let's use a text file here. And this is how the text file looks like. And again, I told you I would simplify things a bit. So this is my password database I'm using for all my projects, right? And well, basically this just shows there is an XML file or there's any file on the file system. Here's the code that does the parsing. So but my Java days are, I wouldn't say long gone, but well, they are gone essentially. I haven't done Java in a while, but I just used the Spring MVC demo application here and just added an endpoint for XML parsing. So I create an XML reader, and then I create an XML handler, more about that later. And then I read in the file. I just read it directly from the file system, but of course, usually that file would arrive, let's say, via post, or that data would arrive via post. And then I do the parsing, and then I just return the output of the parser. Now, the parser is something I kind of wrote myself, so I'm using the SAX parsing approach, of course. But in my handler, I'm doing really kind of boring stuff. It's like SAX parsing in any language. So I have kind of events for start of element, end of element, characters in an element, and I'm essentially outputting it and I'm indenting it a little bit. So really, really boring stuff, right? So really nothing special. And similar in each and every technology. Now, what happens if I run this? Remember, in the parsing phase, what we're doing is we look at the file, and when there is a new element, then we just say, new element, XYZ. And if there's text in the element, we say, hey, we found some characters, ABC. If we do that, actually, let me go here, then let's use the URL. XXE, and that's the output, right? So now the XML parser has resolved that external entity and therefore parsed the local file that was referenced in the XML that I can control in that scenario. And that's kind of shocking here. And of course, I was using the example with the stupid XML that contains a password just to show you, there might be a file with valuable information. But just imagine, maybe it wouldn't be an XML file with a password, but maybe the XML file web config where you have maybe credentials for your database connection, right? I know there are ways around that, but you get the picture, right? Now, as I said, the attack is a couple of years old, and when I heard it back then, I thought, XML, isn't that, is XML still alive? I was kind of irritated. I mean, aren't we doing JSON now? And I don't see the threat. But then I understood, because I'm biased. So I've done I've done a bit of Java earlier, but I've done lots of PHP and lots of ASP.NET. But I shouldn't have left Java probably, because in Java, many of the built-in APIs are vulnerable. So I'm using Spring MVC's implementation here. And actually I'm using the generic Java classes, but also in Spring MVC there's a specific endpoint, and that endpoint was eventually patched. In the .NET space, however, and that's a table I took from the XXE prevention cheat sheet the OWASP provides, all of these different XML APIs, and I mean, given that I've said that XML is kind of dead, .NET has a lot of XML APIs, and all of them are safe by default. The only 3 that were not safe by default are since .NET version 4.5.2. So they didn't even wait for a major version release to eventually fix that. They fixed it in a minor release. So that's pretty amazing. So if you're working with .NET, probably that's something that doesn't you don't care about that much. But just, always remember when you accept any piece of information, have a close look at that and be careful when parsing. Now, just in case that maybe you are working with Java, I just want to add how you can defend against that in my specific scenario where I've used the SAX parser. That's the code that's required here. So we have to call the setFeature API, which I find a pretty amusing name. And then we have to provide the feature as a string. Yeah, excellent. You don't want to know, because I was not pasting this, don't want to know how many tries it took me in order to not have any typo in there. And I was really wondering what didn't work. Right? And then I have to set the feature external general entities. I have to set it to false because it defaults to true, and they don't want to change it. And I mean, I understand that backwards compatibility is crucial, but on the other hand, secure defaults should be crucial as well. And I think in all this GDPR craze, I had to sign so many things, probably many of you too, and I often had also to sign, we are using secure defaults, and yeah, that's exactly what it is. So after that change, let's try this real quick. After reloading it, then it's not resolving the external entity any longer. Problem solved. Now, depending on the stack, and that's what I mentioned. Depending on the stack, maybe that is super important for you and super critical. But maybe you just don't need to care about it because you have a stack where you're protected from that. But let me just finish my thoughts about XXE by mentioning another kind of hype word, and that hype word is server-side request forgery. Now, I assume we all know what cross-site request forgery is, right? So a malicious server somehow prompts a client to send a request to another server that does something. Simply put, now server-side request forgery kind of lets a server or a machine, a server do an HTTP request to another system. Let's just imagine, okay, so I'm an attacker and I contact a website. I send the website maybe malicious XML, as we've seen before. And instead of pointing to a local file, I'm now pointing to a URL. And of course, the system is configured such that the external entity is parsed. So the server I'm attacking is sending a request to another server or to another website. Just imagine that the server on the right-hand side is an internal server that's not accessible from the outside. However, the server in the middle is. And I want to do, or want to send a specific, let's say, just GET request to that internal system, because I know there is a weakness. So that approach could be used to actually abuse this situation. A lot of people are really crazy about server-side request forgery. Personally, I'm not super sure, because you have to know a lot about the internal system, because not only do you need a security vulnerability that allows you to make a server send an HTTP request to another server, but you also need a target server in the end that, accepts an HTTP request, then does crazy things, and you have to know exactly how the URL is, etc. Right? So this might be a bit exotic in some cases, but still I wanted to mention that. So, super important, when you're using a technology stack where external XML entities are automatically parsed, then reconfigure your stack. All right. Next up, and that's also in addition to the OWASP Top 10 2017, and also, again, something that is specific to a certain stack, is insecure deserialization. So we often get data as, let's say, string, right, in an HTTP context. And that string is in a specific format, let's say JSON or something else, and then it's deserialized. And on the server, it's quite often the case, right, that we have a proper language and we want an object of that proper language or a specific type, so we just deserialize it in a type. And there have been numerous examples over the years where some technologies had built-in types that were generally available. And if you deserialize in that type, the constructor of the type does something what we maybe do not want, right? And so these deserializations might go horribly wrong. It's rather uncommon in the .NET stack that something happens because of the libraries. Let's just say JSON.NET. They are now, at least now, secure by default, so you have to misconfigure them, that they are not any longer. But just if you're interested in that, that's why I put it up here, is there's a pretty nice analysis from a while back on the .NET space, and if you're interested in other technologies, there is, again, a cheat sheet from OWASP. And my personal highlight here is a project on GitHub that's a payload generator. Now, actually, I have this open here. And what this basically does is you just try to demonstrate how this deserialization can be used to run code, and then you can choose from a couple of formatters and object data provider, including JSON.NET, but again, configured so that it's insecure, so not the default configuration. And I've prepared a simple call, so I'm using the JSON.NET formatter and the object data provider, and I would like to run calc, right? I would like to run the calculator. And so if I run this, it sets data to the system, and bam, I've started the calculator, right? Just by giving the system something to deserialize. Actually, we see that here in the background, and that the deserializer was running this. So yes, this is a threat because we are talking about code execution, something that we thought would be impossible when using a proper technology on the server. But yeah, it is possible if we do not have secure defaults. Yet still, does this earn I don't even know, number 6 or 7 spot in the OWASP Top 10 2017 before cross-site scripting? I'm not so sure about that, but still, that's something that I see happening quite a bit. All right, again, depending on the stack. Now, how about some oldie but goldie? And I think it's so interesting that I definitely wanted to show you that. So some of you may have seen this before. This is a legendary issue on GitHub. And you know, when you open an issue on GitHub, then you get something like, open this issue a few seconds ago, or open this issue a month ago. In that case, however, that issue was opened 1,001 years in the future. That's interesting. So how did that happen? Now, GitHub is using, I believe, Ruby on Rails, but I've kind of replicated this because it's more or less technology independent. And what I've done is I've replicated this using this Visual Studio version and the built-in wizard to create CRUD views and classes, controller classes, okay? And then I've cut a little bit out of it, so my model is very simple. I've used blog entry as a model, but it's just like, you know, having a ticket or issue. And I have, well, one property for entity framework, but then I have public properties title, text, and date. And of course, the date should be set automatically, so that's exactly what happens here in the constructor. Well, and then of course I have a view, and you know I just let Visual Studio create the view, and the view has, you know, text, title, and would also have the date, but I don't need the date, right? So I commented it out because I don't need it. Okay. Yeah, and when I click on create, then on the server, Entity Framework creates a new blog entry instance, and well, sets the properties and saves it. And actually, we could have a look at that because it's using standard model binding, right? So we automatically get something of type log entry, and then, yeah, we add it. Easy as that. Probably we've seen things like this millions of times, because that's probably code we have, well, we have not written, it was generated for us. All right, let's try this out. So, title, NDC 2018. Good evening. Let's see if this is working. And yeah, now I've created a new entry, and that new entry is dated today and 6/25. Now, how does model binding work? Model binding means I have an expected type, in my case block entry, with public properties, among them title and text. Now, if as part of the HTTP post request there is a title somewhere and a text somewhere, and as we all know, there is an order in which the system looks, post data, and then sometimes even cookie or route, and then it sets the properties of that type. And that is a problem, because if we have a look at our model class once more, I mean, we still have that date property. It is set automatically, but if we send something called date to the server, model binding would also work for the date property. So actually, before I tamper with the HTTP too much, let's just try to use the F12 tools here, might be a bit quicker. So how about we edit this, and I'm just adding at the end, I hope you can see that, input type equals hidden, name equals date, and value a valid date. I never know, is it date month, month day? Actually, I don't care, because I'm just using something that hopefully will just work out of the box. Okay, so I'm sending this along, right, along with NDC 2018 second edition. That's soon. And that doesn't exist, right? Just be safe. And now I've created an entry in the future, right? 5 months from now. And that specific attack is called mass assignment. And I told you I have an older version here of Visual Studio. Because, if you use Visual Studio and use ASP.NET MVC, then use the wizard to create, how it's called, use CRUD with entity frameworks and views and controllers. Then they create those action methods for you, but they add a comment, and that comment says, well, in order to avoid over-posting or over-binding, please explicitly state here either which properties you do want to get bound, or which properties you absolutely do not want to get bound. So we have an allow list and a disallow list, right? And since I was kind of having fun with Spring earlier in this talk, here's just the Java API here, and they also have set allowed fields and set disallowed fields, right? And do that, and if you've ever seen that comment and wondered why, now you know. So please try to fix that. Model binding, or active record, or whatever it is called in other technologies, is super convenient, because I'm working in IT so long, I just don't have time for block entry.text equals request.form of text or something. I don't have time for this, right? And technology does the work for me. Right? But on the other hand, maybe it's binding too much, so we have to be super careful here. All right. Next up is something that actually hit Instagram, and before we go on the slides, I think I'll just show you that. So this is the setup. I have here a page. Let's just imagine that is my Instagram profile, right? So I'm an Instagram user, at least in that scenario, and this is my profile. On that profile, I can control one thing, the link, right? So I will probably say, yeah, you get all the slides, or you get the video of this of today. You'll get that in my Instagram account. No, I think the conference will put it up on YouTube or Vimeo, but let's just assume that, okay? So you click on that link, okay? And I mean, we can have a look at that at the source code here. That's just browser link, so that doesn't do anything. Here, that's all there is. There is no JavaScript trickery, no nothing. Just imagine, that's Instagram. The only thing I control is the link, right? So the text of the link and the target of the link. And then I show you what would happen if I went to that Instagram page and would be interested in the profile of that person. So I click on that link, okay? Again, no JavaScript. The link opens in a new tab. So in the real world, this would be on a different server. This would christiansbadhackerwebsite.com, okay? Now you go on that website, and then you say, I don't see no video here. I want to go away. So how do you go away? You close the tab, Control W, or you click here on the X, okay? Now, what happens as soon as I click on that X? Well, of course, the tab vanishes. But what will you see when I click on the X? The previous page. And in your mind, you say, that's Instagram, right? I was on Instagram. I clicked on a link, nothing happened. I will be on Instagram. And, well, you kind of are on Instagram. The only problem is that Instagram now prompts you to log in again. And I mean, we all tell, our friends and families who are not not in IT, when you enter your password, make sure that, you typed in the URL of that site. Don't click on any links. But hey, previously I did type in Instagram. So yeah, this must be Instagram. I don't even need to check the URL. And that's the problem here. Now, what happened? What did happen is something that was invented by Netscape in, I think, 1996 or 1997. I've been using this for good until I stumbled upon this. I can access the opener, the opening window or tab of a browser window or tab. 1996, pop-ups were invented, a pop-up went up, and from that pop-up you could kind of control the original browser window. So you could have a remote control feature. Back in the days, people, including me, thought that would be a great idea. Oh, wow, have we failed? Now that API still exists. Now we have the same origin policy, of course. So I cannot access the document in that window. Well, here it's all one server, so I actually could. But thanks to the same origin policy, I cannot. But I can access the window object, and I can access the location property of that window object, including all of its parameters, members, like href, or even better, replace, because if I do replace, you can't even use the back button in the browser. Okay. Yeah, and that of course means when you have external links, and those links come from someone else, so if the user can kind of put in those links, for instance, link to the homepage, link to whatever, then you might be prone to that specific type of attack. Now, there are good news, of course, as well, because it's kind of easy to defend against those attacks. The best way is, when you have a link, just use rel equals, and then no referrer and no opener. You have to use both because some older Firefox versions do not comply yet, but these work in all kind of serious browsers. You could also use a specific content security policy directive, but the browser support there is a little bit worse than that. So if you have external links and users can control those external links, that's absolutely what you need to do. Sounds weird, right? I mean, an external link is now a problem, but as you saw, it is a problem. And remember, you open a tab, you close the tab, and then you assume you are in the same position as before. All right. Now, I would actually like to show you. I'd like to show you one more thing, and that's something that has not directly to do with websites, but it has to do with web technologies, and it's an issue that actually ASP.NET MVC once had. And this kind of shows that, we think about very specific attacks quite often. But there's one thing that we often forget, that there are also limits when it comes to computation and bandwidth and any kind of resources. And I'm not talking about DOS or DDoS. I'm talking about something in the application, and that's what I'd like to show you now. This is part of the ASP.NET MVC source code. And what you can do there is a built-in validation. So when you say, okay, this piece of information in the model is of type email address or URL or telephone number, then you can have auto validation of that. So the server and also the client, by the way, they validate the input. And how do they validate the input? I mean, if you talk about email addresses, I'm very easy in validating those email addresses. I check if there is an @ character in it, and that's basically it. But what they do is they have a really, really complex regular expression here. Even for phone numbers, they have a complex regular expression. Now, here, let's have a look at regexbody. This is the phone number regular expression as in use today. And kind of this tool explains kind of what's happening, including backtracking, etc. And then when you enter a phone number, well, that phone number is validated, and once I have an invalid character, it's not a phone number any longer. Pretty nice tool, actually. Costs a little bit of money, but very useful if you do a lot of regular expressions, and you can even click on debug. And then you see how that thing is parsed and that there's backtracking going on, etc. Now, as we all know, complexity sometimes hides underlying issues. So how about I'm using a different phone number. So that one's good, right? That one's good as well. Let's just make it a little bit longer. And then a special character like A. All right. It's obvious, at least for regexbody, that's not a phone number, right? It's not yellow any longer. Let's debug it. Now, you saw that when I clicked on debug before, I clicked on it, snap, and I got the result, and then I had the 15 steps. Okay? Now I click again. Please watch the mouse pointer. And you see there is a delay. There was a small delay. Why was there a delay? Because there's some backtracking going on. But not enough. On backtracking going on. We are still validating, right? Backtracking going on. And after 1 million tries, they just give up. Now this was a short phone number. So you could do a denial of service attack by sending such a specially crafted phone number or similarly email address to the server, and the server was then DOSed by using a regular expression. That is utterly frustrating. Now, actually, they fixed it. So I thought, okay, when they fix it, can they fix it by changing regular expression? Well, the regular expression for the email address, that one did change a little bit. So it's easier now. So the older tag doesn't work. But if we go to the phone attribute, we can have a look at the specific regular expression, but it is the same as I showed you. But what they did is this. They set a match timeout to 2 seconds. That's the fix. That prevents the attack. So only 2 seconds, and the web application continues to run. Don't abuse this. All right. So you see that even older tags are dangerous again. Newer tags sometimes use ancient APIs to be exploited. When you have single-page applications, there are several things you need to take into account. When you accept specific data formats in XML, look for external entities. When you deserialize something, maybe limit the types you are allowing to be deserialized into. And even if you do all that, a regular expression might bring you into issues. So thanks again for coming. I think 2 goals now in the World Cup, so you had a much better time here, I hope. And see you next time at NDC. Thank you very much. Thank you.